Thinking Aloud. Conversations on the leading edge of knowledge and discovery with psychologist Jeffrey Mishlove.
Hello and welcome. I'm Jeffrey Mishlove. We'll be exploring entropy today, the physical phenomena of entropy and its relationship to parapsychology, in particular to precognition. With me is Dr. Ed May, who is the co-author of Anomalous Cognition, Remote Viewing, Research and Theory. He is also the co-author of a 2-volume set of academic papers called Extrasensory Perception, Support, Skepticism, and Science. And he is the co-author of ESP Wars, East and West. That's a title, of course, related to his work as the director of research for a project known as Stargate, the U.S. military intelligence psychic spying program that he directed for over a decade and participated in for 20 years, probably more than any other individual. And during the course of that work, produced more than 100 scientific papers on parapsychology. Welcome, Ed.
Thank you, Jeffrey. It's a pleasure to be here.
I think one of your great discoveries in your 20 years of extensive research on extrasensory perception is the notion of the importance of entropy. Let's talk about how that began for you.
Okay, excellent. For years, both within the contracting world of SRI International and science applications and what the government did, there were a class of psychic spying that, it's going to sound strange, never failed.
Mm-hmm.
And what were that class of characteristics? They were underground nuclear explosions, rocket launches, static rocket motor testing, and electromagnetic pulse devices. And I thought,
these are the targets.
These are the targets that we were spying on in Russia and elsewhere.
Mm-hmm.
And I thought, well, what's going on with that? And I thought, well, maybe our good psychics like Joe McMonagle have seismic feet. They can feel the ground shake slightly. But the problem is, over half of those targets were done precognitively. So the Earth isn't going to shake until the bomb goes off.
Yeah.
I thought, I'd like to be able to look you in the face and say, I made a really important, rational thinking that got me to that position. But frankly, it was a lucky guess.
Well, science works in strange ways.
Lucky guess is a lot.
Yeah.
This one, there are two things we might consider. When an atomic bomb goes off, it's a huge release of energy, right? Kaboom.
Yeah.
The technical term is called kablooey, but we don't go that. And but that would require energy coming backward in time. We didn't know much about that. So I said, well, it must be entropy. So what is entropy and why would I come to that conclusion?
Well, just a second, though, Ed. What would require energy going backward in time?
Well, if it's a precognitive nuclear explosion that's going off tomorrow, how would that energy propagate backward to here now?
All right. Okay.
So I thought, well, okay, let's look at entropy, and why not? So what leads me to that? First of all, what is entropy? Entropy is just a formula that tells you a measure of chaotic things. For example, an ice cube has atoms, molecules of water, all neat little rows. We call it an ice crystal. It's really lovely. You put it out in the sun here, and it melts. And now all of a sudden, things are much more random and more chaos. There are ways you can actually compute that amount of chaos. That's called an increase in entropy. For example, if I have a glass on a table, and I knock it off, and it crashes on the floor, well, I pick it up and put all those pieces on the table again and knock it off on the floor. We could do that forever, and you would never end up with a full glass on the floor. And the technical jargon that describes that situation is called the second law of thermodynamics. What that means in English is things always evolve from less chaotic things to more chaotic things. Humpty Dumpty sat on the wall, and so on. We know that little nursery rhyme.
Now, this may seem counterintuitive to some people because they would say, well, as I grow and become older over time. I become more knowledgeable, more wiser. My orderliness increases. So I think we need to add the bit about the closed system.
Yeah, that's true. That's with regard to the second law. That's true, but you don't need that with regard to this increase of chaos. Now, you're talking about psychological chaos, as an older person, but your atoms are not necessarily, in fact, they're more chaotic in your body.
And that would be aging, I
yes,
suppose,
of course, right.
to some degree. But the point I'm trying to make is that entropy can decrease. Things can become more orderly if energy is pumped into a system.
Right. That's also true.
Yeah.
All right, let's take the example that physics people like to talk in beginning classes. Let's have a glass of water, and somehow magically I put a tiny drop of ink in the middle of it, and I take a video picture of what goes on. Well, we know over time the whole glass will turn slightly blue if it's blue ink.
Yeah.
And if I pulled a trick on you and showed you that video backwards, you say, for crying out loud, you're showing it to me backwards. Well, how do you know? Because that's not the way the world works at our human level. Time marches forward. It's called the arrow of time. But there's a problem here. Suppose, like Honey, I Shrunk the Kids, I get somebody with a very tiny little video camera, and we look down at what's actually going on. Here's a big ink molecule, and here's a big water molecule, and they go bang. But if you run the thing backwards, it goes bang. And you cannot tell what direction time is going when I show you that video. You couldn't tell me whether I was running it forward or backward. That's a fundamental law of physics. At the microscopic level, time can go in either direction. You get the same physics. But at the macroscopic level, where we live, it all goes in one direction. That's
because of entropy.
Because of things are getting more and more complex. One example is if I have a book where all the pages are nice and ordered, and I rip the spine off the book and toss the pages into the air, they'd come settling down. They could land, in principle, the way they were all ordered in the book.
Yeah.
But the chances of that are infinitesimally small because there are lots of ways it can land where the pages are all out of order.
You use the term, things become more complex, and I don't think you mean to say that complexity is equivalent to entropy.
Well, it can be. Well, no, it's not. Complexity can be more chaotic. Things that are chaotic are very complex. So that probably was not a good word.
Okay. Things become more chaotic. Complexity, I know, is slightly different.
Sure.
Yeah.
Well, let's go back to that book example. If the pages are scattered down, that is a way in which we believe the relationship between the order of a book into a disordered array. That's an increase of entropy. And if I show you that movie, you know exactly which direction time is moving.
And I think it's fair to say that many of our viewers will have learned about entropy in their elementary physics courses.
I believe that's the case.
Yeah.
So let's look at what's happened in the parapsychology lab. I'm a data-driven guy. Okay. So what we found in the remote viewing research is that if you have a target that you're doing remote viewing of, let's leave precognition aside, and it's very chaotic, like your target is a power station where there's a lot of stuff going on, that's somehow easier to see with your psychic vision than a playing card on a desk somewhere.
Yeah.
Because that's more chaotic. Or if you really want to do spine kinds of things, use your ESP to look for radioactive material as opposed to cocaine. What's the difference there? Cocaine is just harmless little white powder sitting there not doing anything, but radioactivity is doing all kinds of stuff. It's a higher entropy. So what we found, two things. One is entropy is related to the direction of time. Wow. And we also have independently that entropy is related to the quality of remote viewing. The more change of entropy, the better the remote viewing.
And as I understand it, even in conventional sensory research, it's been found that entropy has something to do with normal visual perception, for example.
And in fact, what's interesting about your vision system, if you could stop your eyes, stare at a spot of the wall and stare at it, your eyes actually are doing this. But if you could stop that from happening, your experience would be completely blank. You would never see anything. In fact, that's somewhat true of all of our sensory systems. They are better at sensing things that are changing, like a blinking light on a cop car is very easy to see. If it's a steady light, it's more difficult to see. And we said, well, if ESP is somewhat like the other sensory systems, there must be something that it's easier to see when that thing is changing compared to when that thing is static.
Right.
And we found it. It's entropy. Entropy, when it's changing, is easy to see, and when it's not changing, it doesn't affect anything.
Mm-hmm. Well, that would suggest off the top of my head that if I were going to use a picture as say a remote viewing target, that a motion picture should have more changes than a static single snapshot.
Well, that was an interesting idea that came forward out of the Gonsfeld research at Maimonides Medical Center, that dynamic videos made better targets. We looked at that really carefully in our lab, and we cannot verify that was the case. It was it may have depended upon the video content that we were seeing to try to compute it. And it's more difficult to compute changes of entropy with a moving picture compared to a static. Now, a static picture isn't moving at all. So how are you telling me there's a change of entropy? I hear you ask.
Well, now we're getting to the heart of the problem, or to the heart of your research finding, I should say, because you did this analysis of the gradient of entropy as it is associated with various remote viewing targets.
Right. Well, gradient is just a fancy way for saying change.
So, and that could be a change in either direction.
Absolutely. So now we have a photograph. Nothing is changing at all. It's just a picture. So it turns out that the formula for computing entropy when you have a kerblooey going off in an atomic bomb is the exact same formula if I say, look at pixels in a picture. I use the exact same formula. The only difference is there's a constant out front, but who cares? And so I can compute the entropy across the picture. The entropy for this little patch, and so on.
I understand this is based on Boltzmann's famous formula for entropy.
I've just recently discovered it's carved on his tombstone.
Yes.
So he's getting more entropic as days goes on. Never mind.
But his formula lives on.
Exactly. So the idea here is on a picture, it's too technical to go into and it doesn't matter. There is a way of computing the entropy of little patches across a picture just by using that Boltzmann formula. And then we've all seen topological survey maps when we go hiking. When instead of, when you do hiking, it's distance on this axis and distance on this axis. Well, we can make a topological survey map like, instead of having distance along that axis, it's entropy on the vertical axis.
And I know you have those diagrams. We'll show them so our viewers can see exactly what you're talking about.
Okay. And then it's kind of like if you had to hike across this domain, if you had to climb up a big entropy hill, that's a big gradient. It's a big change. So you can actually compute the average gradient across a picture. Now you say, okay, all of our pictures, we have a number of the average gradient of entropy for that picture, and they're varying all the place. And what the research shows is that the more change of entropy there is, even in a photograph, the better the remote viewing. And wow, that is so important because since entropy is related in our sense of why the arrow of time is going one direction, precognition says, hold on a minute, not so fast. Time can go backwards. Both of those things are related to entropy. That doesn't yet solve a problem, but what it does do is point us in the right direction because it said those two totally separate issues are now intimately related to help us understand how precognition works.
And once again, those two issues are that A, entropy is related to the direction of time.
Yes.
And entropy is also associated with the most successful targets in remote viewing.
And how good the remote viewing turns out to be.
So a target with a high gradient of entropy or change in entropy, either more or less entropy, is going to be somehow more attractive.
It's kind of like a flashlight in a dark room. Now, we just recently completed an experiment to test this instead of pictures with real sights. And we created an entropy bomb. It wasn't a huge bomb at these sites. Like the old style remote viewing, we have an outbound experimenter randomly chooses a site and goes and stand there. And the remote viewer tries to figure out what's going on. Of course, we all do this precognitively, so the site is chosen after the response is given. And half the time, our outbound experimenter had a bucket, and she poured 3 liters of liquid nitrogen, liquid air, into this bucket, and it would all evaporate after 8 seconds, and that is a small entropy bomb. And we then posited that an entropy bomb at the site would be, cause the person to look immediately. I should look there as opposed to over there, like a flashlight in a dark room. And you know what? It worked. And it worked significantly. And that is another piece of data that says entropy and the quality of precognition remote viewing are intimately related.
In other words, when you have two targets, one of which that are equivalent in every respect that you can tell, but in one of them you deliberately insert as you call it, an entropy bomb. A person goes to that location and creates an event that increases the entropy there.
Well, one thing we had to be worried about in picking these sites, we didn't want to have natural changes of entropy that would override things. So we left things out like power stations and those kinds of things. The sites were, frankly, pretty boring. But that's great because, like, one of the sites was a tree along a path. How boring is that? But when someone stood at that, and it's a real case, the outbounder, Lori is her name, poured liquid nitrogen into the bucket, and I'm doing remote viewing with Dr. Evan Lance, and he says, well, I get a tree and a path, and that's it. I quit. The remote viewing lasted 10 seconds or less, and that was precognitive, and he just nailed it.
And not only that, he knew when to stop.
He knew when to stop. That's a whole separate issue.
But so that's a very significant finding, and it suggests not only that we now know how to produce better targets and how to task people for targets where they're more likely to be successful in remote viewing, we're beginning to get a handle on how time works and how precognition might work as well.
Yes. Well, there's another benefit here. That is, modern physics, modern cosmology is now suggesting that changes of entropy and entropy themselves are more fundamental than gravity. And they're thinking that the way information can go backward in time from the future, this is not parapsychology, this is hard-nosed physics, involves entropic forces. And they're thinking even, oddly enough, to remove gravity as one of the fundamental forces and replace it with entropic forces.
Now that's interesting. As I understand it, I'm not a physicist, but I interviewed many physicists today. There are four fundamental forces. Gravity is one of them, electromagnetism, and the weak and strong nuclear forces.
I'm impressed, yes.
And so what you're suggesting is that entropy is being regarded as a force.
To replace gravity.
And I see. In other words, that entropy will somehow explain gravity?
Yes, from fundamental concepts based only on entropy. A researcher named Verlinde from the University of Amsterdam in the Netherlands was able to derive the famous field equations of Professor Einstein, which explains gravity.
And gravity, as I understand, the little bit that I understand about gravity is that it's also possibly associated with the notion of the curvature of space.
In fact, that's what Professor Einstein in general relativity said. In his way, it's not even a force. It's a curvature of space. So that's one of the problems with gravity. No one has been able to figure out a quantum mechanical basis for it, where all the other forces do, and entropy has a quantum mechanical base to it. So that's one of the attractive things of throwing out gravity and bringing in entropic forces to replace it.
Well, didn't we just say earlier that at the quantum mechanical level, or the level of molecules, time can go in both directions?
That's right.
So that would suggest that entropy is not involved at that level.
Well, the relationship between time going in both directions to apparently time moving in one direction is strictly an entropic concept.
All right. Now, in the macro world in which we live, time to every human being seems to move in one direction, to my knowledge.
That's true. I mean, the cosmetic industry and strollers are part of that, yes.
Yeah, we start out as babies and we grow old. It never goes the other way.
Except in Benjamin Button's movie.
That was a wonderful movie. That was a wonderful movie. But but at the subatomic level, it's as if Benjamin Button could be real.
Yeah. Well, but the observable, we have a big problem on our hands with that only direction, single direction of macroscopic time that we all know and love. There's a problem. It's called precognition.
Yeah.
It seems like the arrow is going backward even at the macroscopic level. So if this turns out to be true and we can measure it and explore it and put it on good, solid scientific footing, we're taking that first or two steps already, then we, in fact, change the whole nature of our understanding of the arrow of time. And we're not the first to do this, as you know. There are plenty of books about the arrow of time, and lots of people have been worrying about that problem.
Well, there's also the issue of psychological time.
Yes. I have no idea what that means. Well, actually, I do.
Sure. Sometimes, I think you told me you yourself once had an experience where time seemed to expand.
Oh, yes. I think everybody has. I drove off an 8-foot cliff when I was 18 years old, and while I was in the air, which physically is only a small fraction of a second, the psychological experience of that was, oh, this is really fine. I don't feel the bumps of the road anymore. And I landed and all 4 tires went, I totaled my car.
Well, is entropy in any way related to that experience?
I'd have to think about it. I'm not sure.
Okay. Well, I don't want to push too hard on this idea because we're already getting a lot out of what we can learn from entropy.
Well, it's part of the model of how precognition works, and we have to deal with, there are 2 domains in that model. One is how does the brain process it, and how does physics allow the information to come from the future to here. And the entropy part directly addresses how the information can get from the future to here now.
The targets that have a high gradient of entropy are more attractive to the human brain.
Well, to the human psychic brain.
To the mind-brain system.
That's right.
To the mind-brain system, both for precognitive targets, for real-time clairvoyant targets, and for normal sensory targets.
Well, this isn't as much of a mystery as it sort of implies it is. Let's say, why do cop cars have blinking lights as opposed to just a steady red light? The answer is the blinking light is a heck of a lot easier to see on the road. Well, a blinking entropy, well, not real light, but a blinking entropy bomb is much easier to see with your psychic vision. So the analogy there is pretty good.
And as I understand it from the point of view of evolutionary psychology, it's likely that when our ancestors, our primate ancestors, were in the savannas of Africa looking for leopards that might be prowling in the tall grass, that a change in the entropy of their visual field would alert them to danger. There's a survival value there.
I like that a lot. It's a sort of an evolutionary hand-waving argument how this might work. You know, because it doesn't help you at all. If you look at the grass, no big deal. You look at the grass again, and it's not survival-oriented to notice that the grass hasn't moved. It's really important that you've noticed the leopard has moved.
And surely a person who has a modicum of precognitive ability is going to be able to potentially survive things that might suddenly jump out of the bushes at them.
Sure. I mean, if you're sitting in your cave and you want to go down to the creek to get water, wouldn't it be nice if you knew the saber-toothed tiger is lurking out there with hell-bent for leather to have you for lunch? And if you could precognite that that's what's going to happen, you have a better survival than if you just want, oh, where did that guy come from? Then you are lunch.
And as far as I know, if somebody could precognize 5 seconds into the future and play the stock market, they would amass a vast, unfathomable fortune.
Well, there's a cute movie with Nicolas Cage in it called Next, where he can perfectly precognize 2 minutes in advance. Gives him a slight advantage when he's avoiding the cops.
Right. So there's enormous potential survival advantages if people can harness this.
But it raises the philosophical conundrum, and we're not going to answer it here, I don't think. And that is, if you could see the future, are you, in some sense, condemned to experience the future you see? And the bottom net of all that is experiments show that that is not the case. Yay.
Well, if it's not the case, then as you've explained it to me in the past, one reason it might not be the case is because we're not seeing the actual future, we're seeing what the probabilities are in the present.
Right. You drive to work every morning, but you have this precognitive psychic dream that you're going to get smashed up and killed in an automobile. Stay in bed. You don't have to go to work.
Well, I don't want to get ahead of your own thinking in this, but if I'm looking at the probabilities, I'm seeing not necessarily information coming to me from a future source. I'm seeing the quantum probability fields in the present moment.
Maybe we need to talk about it at some length, but it's clear that if you go to work every day and it's Thursday, you're going to go to work anyway. The most probable future you're going to experience is go down, get in your car, and drive to work. That's the most probable future,
right?
But you have the psychic dream that says, even though that's the most probable thing I'm going to do, I'm going to get killed, which is highly improbable.
Yeah.
And so you want to avoid that by staying in bed, and luckily we can.
Well, I do know that there's some parapsychology research associated with various disasters, train wrecks, and so on, that suggests that the number of people on, I believe it's trains.
Oh yeah, the famous study. Yeah.
When those trains had accidents was less than the same train a week before or a week following on the same route.
Yeah, they looked at what they called no-shows. There was an increase of no-shows. We actually tried to get the airlines, even a classified study, to repeat that study. And one of our people was on the Federal Aviation FAA board, and they couldn't get the airlines to agree, even at a classified level with us, to do death statistics, because we'd want to know that. They wouldn't let us do it.
That was a little frightening to them.
Yeah.
Still, there is at least a little bit of research that's already been done.
Oh, sure. Yeah, well, that study I think you were mentioning happened in the 50s sometime, where trains were the most way of...
Worth repeating.
Yeah, oh yeah. Well, if you know anybody at the FAA, call them up, please.
Dr. Ed May, it's been a pleasure once again, and very stimulating and stretching my thinking process.
Well, I hope we've made it clear enough for our listening and visual audience to understand what we're talking about.
I hope so too, and I think we probably did.
Great. Thank you, Jeffrey.
Thank you for being with me, Ed. Bye. And thank you for being with us.
Thank you.